I'm Shane Porteous. I'm the engineering lead for compute, storage and networking in Lloyds Banking Group for the private cloud platform. So private cloud typically and Azure don't necessarily go together, but this is one of the things I'm kind of talking about today. So hopefully all will become clear. And my clicker works as well, so that's good. So this started a couple of years ago. We were asked to exit from two data centers that were hosted by another company. And it was one of these things where, get out of this, can you do it quickly, please? Which is great when you've got work like that, because it means you can kind of bend the rules a little bit. Obviously, we're a bank, we're regulated. There's certain things that we need to do, but once you've got that backing behind you, you can do things. Starting off with, let's say, it was two data centers, so the purple ones on here that we're talking about. There was two that we needed to exit. The machines that were in there were no older than 7 years old, something like that, so between 7 years and 0. It was built in a cloud-like way, so everything was on dedicated networks, dedicated ranges, dedicated VLANs, and all these kind of things lined up for making it nice and easy. So you can see we've got our own data center on there as well. We've got more than one data center, but as with a lot of the stuff in here, I'm not going to be talking about specifics because that would be crazy. Also you'll see some IP addresses, some server names, some various bits and pieces. They're all fictional. So yeah, by all means take pictures of them, but yeah, you'll not get anything from them. So what did we select? We looked at various options, so we'd obviously not got room in our data centers for that, and even if we did, it would take quite a significant amount of time to get the kit, get it provisioned, get it in, get it packed, racked, stacked, everything up. So we looked at various options, and what we selected was Azure VMware solution, because all of the workloads that are in the data center we needed to move were VMs. So it just made sense, and they were VMware VMs as well, so it made sense that we could move them from one place to the other, changing as few parts as possible. And at this point, if you were expecting to talk about serverless or AI or anything like that, I apologize. There's a few older people in here, so there's a nice love for servers. So we picked Azure VMware solution. We're a really big Microsoft partnership that we've got. It comes with additional benefits as well. So if you're running things on Microsoft's ecosystem, and this includes Azure VMware solution, you get your ESUs for free. I hate ESUs, but there we go. People shouldn't need them. Anyway, so this is what we're looking at. So Azure VMware solution, you can see here, basically within Azure, you've got a software-defined data center. Within that, you've got a cluster where your machines live that's built up of hosts, and you've got your virtual machines on that. So a little bit of information on Azure VMware solution. So it is basically running a VMware setup in Microsoft's data center. And when it was initially built, you can see at the top, someone said, are we talking about Dell servers later? I think it was Neil. Said, yeah, it is a bunch of Dell servers, effectively, that they've racked in the data center, and it's there provisioned for this purpose. So it's not a standard public cloud model where you've got infrastructure that's deployed and shared and used in that way. It is a private cloud platform that you're building in Microsoft's ecosystem, Microsoft's data center. And that helped us to move on to this quicker as well, because if you are a regulated industry, putting things on public cloud is worrying for people. If you've got a dedicated bit of tin with fairly well segregated networks between you and it, people are happier that this is a private cloud running in the public cloud world, and you've still got the FinOps model and everything like that around it. So this is what we selected, and you can see it's, for those that know VMware, you've got all the standard stuff. So you've got a vSAN data store, which is your disk cluster, effectively. You've got your vCenter, you've got your networking layer with NSX, and then that's how it's built together. So there was different options for the hosts. So at the time when we built this, I think it was between the AV36P and the AV52, and the number just means the number of cores that the machines have got. So you can use that to kind of decide how big a machine you've got. The ones at the bottom, so this is what Microsoft call their fleet hardware. So this is the tin that runs all the other public cloud compute effectively. and you can expand onto that, onto the AV64s, but you can't build a new cluster from it. And that's due to the network layer, and that is being introduced soon, I believe. You can build natively into that. And they've recently introduced the AV48, which has got 48 cores. And you can see on there the options about how much storage you've got, how much RAM, and things like that. So you can use that to kind of build your cluster size. Minimum cluster being 3 nodes. If you, again, for vSAN, it depends on your fault tolerance. So a lot of people probably use 6 node to start with. So that's AVS, and that's kind of what we did. The other thing to consider is availability zones as well. So you can build your cluster and map it to an availability zone. If you've got more than one clusters or more than one software-defined data center, you can put those in different AZs for fault tolerance. So if you lose one, you've got the other. There's also a stretched or a vSAN stretched cluster option, where you build your cluster across multiple availability zones. So if Microsoft loses an AZ, then you've still got service. So that was, I guess, the building blocks of what we built, and I should probably make a note of what time I started talking. But the next thing was, what have we got to move? What's the challenge, and how much infrastructure do we need to deploy? So we said we'd start with dev test, and there was around 6,000 VMs on these 2 data centers that we needed to move. So at that point, we kind of said, well, we've got 6,000 VMs. We're also going to take this opportunity to look at decommissioning where possible. So these are dev test environments. If we don't think they're being used, then let's get rid of these machines. So the question is, well, how big does it need to be, and how can we go about that data? So that was the next challenge. So these are the made-up things. So we looked at what was the easy data that people could get to in terms of the team. It wasn't all engineers. We've got business analysts and various other bits and pieces. So what we used was our systems management database, or CMDB, which is ServiceNow. And we kind of did exports of the data and went, well, actually, these are all the machines, these are the locations, these are how big they are. This is how much CPU, how much memory. So typically you'd use that CPU and memory factor to decide how big hosts you need, and you'd use an overcommit in your VMware world, where it's like, well, it could be 5 to 1. So five virtual CPUs to one physical core that you've got, and you can kind of commit like that. So this is how we did this. And this was the non-engineering data. We also used that recent discovery date, so that's last time it was seen on the network. So we could use that to say, well, actually, if something's not been seen on the network for a while, it's probably turned off. And if it's been turned off for a while, let's decommit. So that was kind of held in the back. But as with any CMDB, there's inaccuracies in it. So it's good to get an idea, but for some reason they're always out of date. So we did some more digging. And what we did is there's a tool set called RV Tools. So you can run that against your VMware environments to do exports of data. And then at the time of putting this picture in the slide, it was VMware ARIA operations. It's probably VCF, VMware Cloud Foundation operations now.
No, ARIA is still a thing.
Yeah. So, and I'll talk about licensing and Broadcom and things like that towards the end, because things are changing rapidly as of today, I believe. So we've got this extra data now, so we could see at the end, we've got the powered on state. So again, with that and the last scan time, we use that to decide whether the machine had been turned off for a long time. We've got the disk sizes now, we've got the IP addresses, we've got all the useful information. So what we did was we just took this arbitrary statement that we said, anything that's been turned off for more than 6 months, we're just deleting it. And we didn't ask for permission. We just went, they're gone. And we delete 1,000 machines like that. It's liberating. We had one complaint. So yeah, look at what environments you've got. If you've got a lot of environments, and just cleanse them. So we'd got that. We've got a lot of data now. So now we were looking at what we were building. We decided to build 2 software-defined data centers, or SDDCs, to match the source. So we'd got 2 data centers that we were coming from. We'd put them into 2 software-defined data centers, where we'd move one into one, the other into the other. and we'd put them into 2 different availability zones. So again, if you lost one, the other one was still running.
And that's within Lloyds banking group data centres?
No, this is in Microsoft Azure.
Yeah.
So this,
it's confusing.
Yeah. So this is the blue down here is in Microsoft Azure. So it's a subscription. It's in one of our tenants that we have with Microsoft. We've got a subscription, and within that subscription, we run 2 software-defined data centers. But yeah, any questions, just ask as I'm going along. Some constraints to be aware of as well. So maximum number of clusters that you can have within a software-defined data center is 12. Maximum number of hosts in a cluster is 16. Maximum number of hosts per SDDC is 96. So these are quite small numbers in comparison to what you could build in your own data center with the VMware limits. But it's all down to the way that Microsoft look after the environment and manage it. And also in terms of vSAN, so that's your virtual SAN, you can only load it up to 75% capacity as well. But all this is available, this calculator for all this kind of stuff. Our existing connection between so Lloyds here and the CNF, or the carrier neutral facility, colo, whatever you want to call it, that remained the same, and then we had to decide what we were putting in terms of express route connectivity. We've got various express route connectivity for public cloud type consummation, things like that, but we decided at this point to put something in specifically this, and we'd worked out that 10 gig circuits would give us more than we needed. Again, I like saying this in a room because I've told Microsoft I wouldn't tell people, but when you put express routes in, you have to put 2 in. So although you want a 10 gig circuit, Microsoft insists you put 2 circuits in so they can take one down and do maintenance at any point. So realistically, under normal non-fault, them not doing work, you've got 20 gig. And us, we go via 2 colos, so for resilience as well, so we got 40 gig. So we kind of, while you can't rely on it being there, you can kind of think, if you're happy to stretch the boundaries, you can kind of boost if necessary. So we've got that, and we went for the pay-as-you-consume option as well, because you can do an all-you-eat option with the express routes as well, which is great if you're using it, but they are quite expensive if you're not. So the next question is, we've built some software-defined data centers. They're there. Next question is, how do we actually migrate our workloads? And this is a bit of magic, really. So there's a VMware tool technology, bit of software called HCX, or Hybrid Cloud Extension. So normal operation, when you've got a VM running on a cluster, these VMs can move around the hosts. It's just vMotion. They just run and operate, and they'll go where they're needed. So the question was that someone had was, well, actually, how can you do that across different sites? And what HCX is, it's a network stretch technology, effectively. So it advertises this network range as existing over here as well. And what that meant was that we could move virtual machines and retain their original IP addresses, which is great because if you don't know what things are talking to, you don't know if people have got hard-coded IPs in really bad-coded applications and things like that. So that's what we did. So we looked at setting up HCX as a stretch, so that this subnet will exist on this. I first said at the beginning, we knew this was on nice clean subnets, so we could go, well, actually, we're not going to break anything by stretching that. And we used a technology called replication assisted vMotion, or RAV. And what that meant is we could actually migrate the machines while they were still being used. So what it does is it sets up a storage replication on the vSAN to say, here's the machine, here's the machine, here's the machine on the other side, but it's still operating here. And then you do a snap when that storage is caught up and the machine appears on the other side. And we did that, and it's like a very split network blip. Doesn't impact service, doesn't cause anything. And so, the majority of our machines, I would say, we started with, I think I said, 5,000 machines. Most of those were migrated across in this way. There are other options. You can do SRM, which is the site recovery manager, or you could do bulk uploads, but they require an outage where you just copy all the stuff and then fire them up at the other side. So we came up with the pipeline. Sorry, if you sat at the bottom, you probably can't see this. So this was our flow of how we did it. So we'd got the data. We said, these are all the subnets we need to move. Let's move them. So let's stretch a subnet. Let's move all the stuff. Once they're all over and we've emptied the subnet on this side, we'll break that stretch and we'll advertise the subnet as existing on the new side. So this is kind of the way that we went through it. And we went through that. So we picked the machines that were migrating, we stretched the subnet, migrated the VMs, and completed some health checks. And that's where I'll pause. Because if anyone knows what happens when you stretch a subnet, it doesn't exist on both sides. It exists on this side, and then there's an appliance on the other side going, I'm here as well. So this arrow shows two machines over on this side here talking to each other, but they go where they're advertised. And then the HCX goes, no, I'm here. So if you can imagine, you've got a stretch for it. So every request is comedy word tromboning from one side to the other. This can cause problems. Under most things, doesn't cause you problems, but there's some applications that might be latency sensitive, or might be working in a cluster or something like that it just upsets them. And into save the day steps, mobility optimized networking. So what we found is, so this is the configuration. You can't have it across the whole thing, but you can enable it on your subnet. You can go, yeah, this machine, enable it for mobility optimized networking. We just advertise the fact that it's not here, it's here, and the NSX kind of HCX technology just looks after it, talking to its neighbors. So that's really good for if you're copying big files around between two machines there. It just copies them between each other. So it goes at NSX at the edge, and then it doesn't bother leaving the edge to the other side. It just copies it across. So we identified some problems. We fixed the problems. Back on with the work.
So you migrate groups of VMs per subnet?
Yeah. So what you do is you set up your replication task, and you go, these, replicate them over, and it'll just start copying all the storage, synchronizing.
VMs which wouldn't replicate across, as you said.
Yeah. So we had some things where things where we'd identify where versions of VM tools. If you got an old version of VM tools for some reason, then you couldn't do it because you needed to update the VM tools. And the short answer is, well, update the VM tools, but that often needs a reboot of the machines as well. So well, actually, what's the easiest way of doing it? There's some things where there's always just some weirdness that happens with things.
So if you're migrating 10 VMs in subnet 1 and one had a problem, would mean that
it would only be the other 9 would work. It'd just be that one that these.
So what happened? So that one just gets left.
Yeah, it just fails, and then it gets reported as failure, and then you address it. So we addressed it, fixed it,
and then do the same process.
Yeah. Or if there is an underlying problem with it, then you migrate that using a different way. So using SRM, or you do a bulk thing where you copy it over, you turn it off, you start on the other side. So that was the approach we took and finished off this. And the plan was, we'd do a subnet, we'd empty a subnet, we'd swing the subnet, we'd move on to the next subnet. In reality, we got about 50 subnets stretched, because there was always like one machine that somebody says, oh, you can't do that one yet because we're doing some critical testing on it. And so the majority of the moves we did without asking, but it was when something failed and caused someone a problem, that person became aware of the work we were doing and kind of blocked what we were doing. But I guess going on to the last slide, was that seen as a success? Yes. So we migrated 5,000 machines. We got rid of 1,000 machines. Majority of them were done without people noticing. There's probably people still don't know their machines are on AVS now, and they still think they're in that data center that we moved them over. So it was generally a success. HCX migration technology just worked. It was great. As I said, but there were problems. And the problems were, the unknown and unexpected caused us issues, like things having rancher clusters that they weren't supposed to have. And these are development environments, so it's not lawless, but it can be lawless. But people build critical things on them, and if you move them over and they fail, they get upset, which kind of stretch networks can cause problems. If you've got something that are super latency sensitive and you move it and it's used to 2-second latency, but because it's going, you might be talking 8-second latency between one side and the other, but in a stretch it's 8 second that way, 8 second back. Some things can get super upset. But the other thing was we got blamed when anything broke. Anything. Once people knew we were doing this, as soon as their application stopped working, or there's a problem with the express routes, we got the blame. Or we had to prove it wasn't us.
How did you prove it wasn't?
You know what? It took a lot of time. It took a lot of time. One of the weirdest things that happened. I know I can talk for ages, so please drag me off if I'm talking too much. So one of the funniest things that we had was we were doing some migrations, and VDI, because we use Azure for VDI and things like that, started slowing down, and we're like, but we're not. We've got our own dedicated express route. Why is VDI slowing down? So we stopped the migrations, and VDI's recovered. We're like, well, that's a bit weird. And then we flipped over some stuff, and then it was this that was causing it. So it's like, okay. So we start our migrations again, and the VDI starts slowing down again. And it turned out that in the colo there was some Cisco switches where, although they were licensed for 10 gig connectivity, when they were installed, someone hadn't flicked the 10 gig switch, so they were running at 3 gig. So our 10 gig pipes were topping out the switches. So whilst we'd not caused it, we kind of had caused it, but we fixed it. So everyone's VDIs were much faster after that, and you could do video on VDI that you could never do successfully before. But it was this thing of you need to understand the infrastructure underneath it a bit more, and that was one of our learning points. Is we just went with we're moving subnets, we're doing it, and we did a lot of analysis retrospectively. So job done. That job was done. We were then said, right, well, actually, we've got all this really old stuff in our own data centers that, while we're planning on things to do, can you move them? So we've not got to do a massive refresh on the underpinning infrastructure. It gives us some breathing time. Okay, fair enough. We thought we'd have a rest, but on we go. And in terms of this, where I said this is the old stuff. There was about 2,000 machines on here, and whilst where we started was new data centers that were migrating from things that had been built as cloud platforms, this was it's at least 7 years old. It could be 20 years old. It could be something that somebody built yesterday unofficially. All this stuff. So it's the difficult thing. So it's like, right, okay, how can we take the learnings and make this work a bit better? Because this is the hard stuff. It's only still there because nobody else has been able to get rid of it. So it's like, well, how do we take what we learned in phase one and kind of make it better? So next question. This was the network team going, how do you know there's no physical servers on these VLANs? You can't swing and stretch and flip VLANs if there's physical boxes on it, because you're only moving the VMs. And it's like, yeah, we don't think there's any. The CMDB says that there aren't any. And one of the guys from Broadcom came out with a brilliant idea, which I do like talking about because it saved us. And he went, well, all the VM's MAC addresses will start with 0050. Okay, so if we do a ping sweep effectively across the network and go everything respond, and then you get the ARP cache and you go, give me the MAC addresses of everything that's responded on this network. So that was the approach we took, and nothing responded with a MAC address that wasn't 0050. So we were happy now. It's like, right, everything on this network is a VM. We could take the same LAN-based approach of just migrating stuff over there. It took us a lot of time to get to that, and a lot of heated discussions with networks, who by this point were our friends. In the first phase, when we were moving things and we were talking about network stretches that they weren't doing, it was interesting. So I've cut out some other stuff as well, but we kind of married that network data with the CMDB data as well and got to that same point. So the next bit was we then had to review our express route connectivity. You know, we'd put in 10 gig based upon what we thought we'd used. Worked out that we were topping out about 8 gig while we were doing migrations. And then once the migrations were finished, it was tickling over about 2 or 3 gig. So we got plenty of room for doing additional stuff. And we got that burst capability that I told Microsoft I won't tell people about. So there you go. So next thing is, well, actually, we understand that express route connectivity. One of the things that bit us last time was around, you know, we just moved stuff. We didn't do any analysis. And we still, you know, we're still not doing analysis. We didn't talk to the application owners. We just moved things. But we still wanted to do an infrastructure-led approach. We didn't want to talk to the application teams because it slows them down. Apologies if there's any application people in here, but you slow us down. So we use some more of the VMware tools, so affectionately known as Verni. It's not called Verni anymore, so it's vRealize Network Insights. I think it's VMware VCF Operations for Networks or something. And we use that to identify the top talkers. So in terms of the networks that we were looking at, or the VLAN we were interested in at the time, you know, what's talking a lot, what's moving a lot of data around, or what's opening a lot of connections, what's really chatty. And we use that to identify the applications that we really needed to be interested in. And in terms of, you know, are they across multiple VLANs? Are they all in one VLAN? Do we have to move two VLANs at the same time because things are talking to each other? And we did that, and then we broke them down as well. So another kind of view from the tool. Again, it's all made up data. And you can see you can break it down into like app servers and SQL servers and web servers and kind of use that to go, right, we understand what's talking to what the problem is. Let's move it on that basis. We also kind of pre-identified where MON would be needed or where MON would be beneficial. So the mobility optimized networking. So it wasn't a reactive thing that we're going, oh, it's broken, let's see if MON will fix it. We've gone, well, this is talking to this a lot that's going to be next to it. As part of the migration wave, I think we should pre-enable MON on those devices. The first phase, it was very much we'd worked out right at the start how much infrastructure we needed, and we dropped it on the floor. And it's like, right, boom, this is the SDDC, these are all the clusters, it's all there. Microsoft Group, whoo, you know, because as soon as it hits the floor and you turn it on, you're paying for it. There was various reasons for taking that approach for phase one that I'll not go into, but we wanted to do infrastructure delivery on demand. So, you know, the next question was, well, actually, how can we do that? And it was in the wave planning as well. So, you know, so we'd picked a wave and we'd gone, there's this many VMs, they're this big, they've got this much CPU, they've got this much storage, they've got this much memory. So we can predetermine, well, actually, we need a footprint of this big for this wave. And then as we move on the waves, you can scale a cluster by just saying, well, add an extra host to it. And this was the way you had to do it, whether you use vSAN, which is it uses the internal disks in the hardware to build up a SAN array effectively. So you're not using external storage. You're not using external memory. You're not using external CPU. So you can't scale them individually. You have to put them on as blocks and you get CPU, memory, storage. Boom. So this turned into our new flow effectively. So, you know, migration wave was started. So we'd stretch the network. We'd enable MON for the things that we'd identified as needing enabling. We'd migrate the VMs in the wave. We'd complete the health checks. Much better. We have less failures in this one. And then before we'd go around, we'd scale the clusters if needed. We'd go, right, ready for the next one. What needs to be done? Do we scale out the clusters? Do we add a new cluster? Move them all across, swing the network, go around the block. And that was effectively the new model that we took. And so it was much more of a success. We saw much fewer issues. We still didn't have to talk to the application team, so we decommissioned more machines as well. But what we found is when we were doing the first one, because we were hitting problems, we kind of the timescales were slipping, and we weren't kind of keeping up with the schedule. What we found in this one is we were actually going ahead of the schedule, so we were having to replan, and we'd engage with the teams better as well. So in the first phase, the network team were very much a transactional. Will you do this change now? Yes, here's or whatever. Whereas this, it was we built a team and we were regularly meeting like, right, we've predicted this change on this date. Can you come in? So we worked a lot better. We saw fewer incidents, much better management of costs as well, because we dropped the kit on the floor.
So you just on the previous slide. So when you start the actual new migration started.
Yeah.
How long before you can actually get to your network swing? A week, 2 weeks?
It all depends on the size. It depends on the number of machines on that VLAN and the difficulty of getting all of those machines on. So realistically, let's say you've got a few hundred machines on it. If you got everything lined up, you could do all that in a couple of days, including the swings and everything. But it's, there's certain things that just slowed you down. So, which is why we ended up with more stretches in place than we wanted, but we did get quite a good cadence of doing the stretch, migrating, flipping the network over, getting rid of it. So it all depends. And we'd use the same team doing the migrations as well. And after this, there was actually a phase 3 that I'm not going to talk about, where we did some more stuff. So we've got another set of environments. I didn't have to get involved at all with that. It was just like, do those migrations, yeah, okay. And so if you've got the same people doing it and they're building up that cadence, it turns into like a muscle memory type thing. We still upset people. Yeah. But we got an increased advocacy of what we're doing. So as well as that, as the migrations, we'd set it up so that all new VMs in dev test environments were provisioned in AVS. So people got more flexibility. They were running on much newer generations of CPUs and things like that, so the machines were running a lot faster. And one of the other things that it gave, and I should have said at the start, I'm not advocating Microsoft or VMware or anything like that. I'm a bank employee. I'm just saying what we did. But if that's your strategy and you've moved the machines in there and you've got a public cloud strategy as well, and let's say you've got a SQL database running as a PaaS service. Well, actually, if your application that's consuming it's in AVS and it's running there, it can just talk direct to it over Microsoft Backbone. So you've not got to worry about express routes and ingress and egress charges effectively and things like that. So there are lots of really good reasons to do it. So when we started this, however many years ago, two and a bit years ago, VMware was VMware, and it was nice and easy then. After we'd finished the first boat, and it took us about 9 months end to end from idea to doing that first thing. VMware were purchased by Broadcom, so which was great because I get on quite well with Broadcom, so I'm not going to. No, other people don't. But it gave us a fixed cost. If you did reserved instances, we knew how much we were paying. It included the Broadcom licensing. So if you fix them for 3 years, 5 years, whatever, you kind of set. And that was really good because I know that some people were having problems with Broadcom once they depend on the SKUs that they had. And that was kind of just nice and easy. As of, I believe, today, I've not kind of seen any announcements, but I know it's predicted today, you can't purchase VMware licenses from Microsoft anymore. So the option for this is to bring your own license now. So you can it's still a service, you can still use it all, but you have to bring your Broadcom licenses to install or to show Microsoft I can run this software. Which has kind of changed the position a bit. But again, if you're a big enterprise that's done a recent deal with Broadcom that's been advertised, it's not a problem if you've got lots of cores to use. But it's other things to understand, and other things to understand around that scaling, the building blocks. Not talked about it as well, but there are other things you can do. I think you can use Elastic SAN now to scale out your vSAN. You can use our NetApp files. I think Pure may be an option as well. So there's lots of things that you can do for that. I mean, for us, it was a great bit of work. It was really fun, and I'm glad that people have asked questions about servers, and it's not all about serverless and containers and Kubernetes and AI and stuff like that. But that's me done, babbled on for about half an hour, 40 minutes. Any other questions or anything like that?
You moved your VMware setup in Azure. So that was, I think it came with loads of benefits, but probably you need extra or new skill set for loads of things.
Yeah.
And it was faster. But what's your long-term plan? Are you going to stick to VMware for good? And do you not think that you are missing out some greatest and greatest?
Yeah. Yeah, so as Lloyds Banking Group, as Brian says at the intro, the desire for Lloyds Banking Group is to be the UK's biggest fintech. So if I was just stand up here and saying we're just going servers and IaaS, that's kind of going in the face of that. Our infrastructure strategy is to use the most appropriate place to do things, depending on what it is. So if we've got an application that's based on IaaS now, and the business isn't transforming that for any reason, because there's various reasons they'll have different focuses, then it makes sense to keep it on an IaaS platform. If a business is transforming an application, then the default option will probably be public cloud or Kubernetes, or potentially on-premises Kubernetes, depending on what you need to be. So it's not, IaaS isn't the answer. This is an answer for a specific problem. We've still got a huge platform on premises for running this kind of stuff as well. We've got things in Azure with Microsoft. We've got things in Google Cloud Platform. It's where it needs to be done. And one of the things that Lloyds is working on is we've got, and it's not something I'm directly involved with. We've got it's referred to as internal developer platform, or IDP. So it's a single portal for application developers or business users to access via, and they put what they want to consume in terms of that they want a Kubernetes cluster, and that will kind of put it in the most appropriate place, or do they want a server, and that will put it in the most appropriate place, so that the application developers shouldn't have to understand where the infrastructure is running. It should just run, and it should run and give them what they need regardless of where it is. But yeah, it's not all just about private cloud. It's about putting things where they need to be.
Any questions? You mentioned reserved instances.
Yep.
At the last part.
Yeah.
Did you measure? I mean, I realize you just deleted 1,000
Yeah.
VMs, but did you measure the impact of reserved instances?
From a cost perspective. So we didn't do the cost analysis of reserved instances versus what it was costing on-prem, because I'll say the first one we just had to exit the data center. The second one, it was very old infrastructure that we just needed to replace. So in terms of how does this compare to on-premises, we're going through some of that right now in terms of developing a new platform, and we're going to charge and take a FinOps model for our on-premises platform in the same way that we would for consuming this. So we will have that data, and we'll use that to best decide, where should we be putting our workloads? Is it using an on-premises model? Is it using AVS? Is it a hybrid? I think it all depends on your own data center and how you run it and how efficient it is. And there's different options. But I mean, say if you do know you want to keep it for a while, then the reserved instances are the way to go, because you can get some really good savings, but you're obviously committing to having it there. So we ran the AV64s because they were fairly new. We didn't know whether the AV64s would cut it because they got much smaller storage. But you got much more CPU, so it's like, yay, more power, but not quite as much memory from a ratio and a lot less storage. So we didn't commit to reserved instances on the 64s until we'd proven additional storage and things like that. RIs are great, but use them appropriately.
I think I'm quite used to seeing Azure advisor come in and say, oh, that's the wrong size, you should make that smaller, or you benefit with reserved instances. Do you get that with the AVS service or not?
You don't necessarily get that. I don't think you'll get that in terms of the RI recommendations. refer to Microsoft or something like that. So what you do get is within the VMware tooling, you'll get your virtual machine's too big, it's too small, or your clusters are running too hot. So you can use that to do your scaling. I'll say, typically, I think previously organizations have used hard limits to say overcommits of like 5 to 1. You can use the tooling now to go, well, actually, I can squeeze a bit more out. We run the AVS stuff really hot. It's that balance of, well, if you lose a host, what's the impact versus getting your bang for your buck. We were at a VMware event 2 or 3 weeks ago, and they were saying how they run their infrastructure on premises. They run the hosts at like 80-90% CPU for their internal things, and it's like they're aware that if they take the hit, the host goes, then some people are going to be upset. But it's getting that risk versus cost versus sweating your assets.